For this video, let's fully design a retaining wall. Opening up this Cornerstone software, let's choose Layout. Let's go to Blocks, and MagnumStone again, MagnumStone All again. Let's choose all our blocks, and GeoGrid, and once again, we'll choose our GeoGrid specs. Now we'll go to Default Design Data, and we'll see options for design method, and wall geometry like batter and leveling pad and embedment, soil properties, seismic factors, and drawing size for once the wall is complete. Now let's go to the Draw tab to define the wall layout. If you have a plan for the retaining wall, hit Plan View. If you don't have a plan, but have wall information and wall changes, go directly to Wall Layout. Since we'll be looking at a plan, we'll do Plan View and go to File, Convert PDF to Image, and choose the plan. Let that load, and the first thing we'll want to do is adjust our scale. First we'll go to a known dimension like the scale bar, and we'll zoom in to maximize accuracy. Then hit the ruler icon and measure the dimension. We'll hit Scale Drawing and input the length in feet. We can delete the old measurement and measure the dimension again to make sure the drawing is now to scale. We can then zoom into the retaining wall and use the Polyline function to draw the wall. You can see some directions at the bottom here with a note stating to start the line at the left end facing the wall. Since the toe of the wall is on this side, we'll start at this end and click all the vertices of the wall. The software interpolates data like the slopes and load between points, so if there are any significant changes, you can add a point to any of those locations. You can see the slope and bottom of wall elevation changes dramatically in this area, so we should add points to both sides of it. We can do that by using the Add Polypoint function. You can use the Remove Polypoint function if you've added too many points. To add wall elevations, we'll then hit Get Points, where a table will show up. We'll hit Get Points on this table to gather the data, and we'll have options to add the top and bottom of wall, limit embedment, freeboard, and inside corner, outside corner, and begin and radius. We can then start adding the top and bottom of wall elevations. Fast forward, after adding all those elevations, we can add number points and plot coordinates if we want to add the point information to the plan, and then hit Send to Drawing. If we close this and go to Wall Layout, we can see that the points and elevations were transferred over. Like I said before, if you don't have a plan but have the changes in distance between points, you can add it manually here. Now for each point, we'll add in slope and load information. There's back slope, toe slope, live load, a second live load, and dead load. For slopes, we can go back to the plan and measure the toe slope length perpendicular to the wall. Looks like about 14 feet, and based on the contours, the difference in height is about 7 feet. If we add these values to the calc slope angle and hit Tab, it'll give us a slope angle. We can add that with the length here. We'll do the same for the back slope. The length of slope is about 11 feet, and the difference in height is about 4 feet. So a slope of 20 degrees, 11 feet long. For live load, let's go back and measure the road width now that we have the distance to the road. We'll add those values and say 250 pounds per square foot for the live load. You'll then do the same for all the points. Fast forward now that I've added those. If you leave anything blank, you'll see here that the program will interpolate between points when the wall is drawn. Once everything's filled in, you can hit Draw the Wall, choosing either Gravity or Reinforce Wall. That creates an elevation plan layout in the design window, and other results and reports that we'll go over in the next video.